Hey everybody, what's good? What's going on? JB here, back with another CyberInsight live stream. And today we're going to be doing lab number 4 of my CCNA, CCNP OSPF series that we've been doing. And this is actually going to be, I think, what's, at least in my mind, going to be the final OSPF lab that we're going to be doing. We might end up coming on, later on down the road a little bit and doing one related to IPv6 with OSPF version 3. But as far as the v4 stuff goes, I think this is going to be the end. So in today's lab, we're going to do a little bit of a recap of all of the different things that we've covered. And we're going to tackle one of the last things that we haven't really done yet, and that is how to use virtual links to end up connecting areas that don't have a direct connection to the OSPF backbone. So let's go over and hop into CML and get busy with all that. And as I'm doing that, as always, smash the like button, subscribe to the channel, all that other good stuff that helps me out. I appreciate it. And as we're moving through this stuff, if you have any questions, you can just go ahead and throw those in the comment section and we'll try to hit those up. So if you've been following any of the previous labs, then you know that all of this stuff is up on my GitHub. There's a link in the video description for where you can go about getting that. There's also some other links to some background information on OSPF and some of the different topics that we're kind of covering here. So if you do go to the GitHub page, you can go into the OSPF folder and then into Lab 4. And you'll see that we have this diagram here. The diagram lays out in essence, a pretty small network, but all of the different things that we're going to be doing in this lab. And then we have various tasks that we're going to be going through to configure to end up reaching our specific objectives. So if you're starting off, the way that I've kind of laid these out is that you have some baseline configurations that you can go and you can copy and you can put these into whatever devices you might have in your own lab. And that pretty much will get you to the point where you have layer 3 connectivity between all of the different devices in the lab, but we haven't started to implement any of the OSPF configurations yet. So this is a good starting point. And if you also have CML, then you can actually take this YAML file here and you can implement it in your own lab, and it will end up at least physically putting those devices into your lab environment, and then you can just copy and paste these configs in there, and then you should be good to go. So let's go back to our diagram that we have here and kind of take a look at the overall network, what we have going on here, and take a look through the different tasks that we have going on. So kind of similar to the network design that we had in last week's video. I think the only difference is we're kind of creating this 5th area over here on the left, where last week area 1 kind of encompassed this whole area here. So pretty straightforward, a whole bunch of /30s between these different routers. Router 1, router 2, router 3, and router 4. Each of those different routers has its own separate LAN segment, which is a /24 that's hanging off of those as well. So something to just keep in mind there. As far as kind of the numbering that we do here with these and the router IDs, I tried to match it up with whatever the router numbers are. So in this case, the LAN subnet is .1. LAN subnet over here is .2. And then same thing for the router IDs. We're going to go router ID of 1.1.1.1 on router 1. And then, similarly on router 4, it's going to be 4.4.4.4. So pretty straightforward stuff. You can go ahead and poke through the configurations that are in the base config section on GitHub to kind of figure out what everything needs to be. But we can go ahead and just consider that first task here is done and good to go. So just to kind of go and verify that, we can go log into these guys. I'm just going to show IP interface brief, and we can see that these interfaces are up and good to go. And since we have to get into these anyway, then I'll just do it on all of these. I'll just make things a little bit faster here when we actually go to start working on the other tasks. So I'm excited to wrap up this OSPF stuff, and I think the next thing that we'll be doing from a CCNP perspective is we'll start doing some BGP labs here shortly as well. And actually, if you go onto my GitHub, you can actually see that the first lab that we're going to be doing for BGP is actually already up there, if you wanted to go and kind of get an idea of what we're going to be talking about on that first video that we do for that. Okay, so everything looks good to go. Everything's up. All those connections are good. So let's take a look at what we have for task number 2. So we're going to set up OSPF in area 0. So that's going to be over here. And if you kind of remember in the first few labs, we were doing interface commands to set up OSPF. In this case, just like last week's lab, we're going to be using the network configuration commands. So we're going to be doing that. And then we also want to make sure that no OSPF hello messages actually go out any of the LAN interfaces. So that's going to be GI03 here and GI03 here. So in order to do those things, we're going to go ahead and just create the OSPF instances on both of these. We're going to set up the router IDs, as I mentioned, so 2.2.2.2 over here and 4.4.4.4 over here. Then we're going to put in OSPF network statements on both of those. And then we're going to be using a command that I think we might have done in one of the other labs, but it's a passive interface command. And we're going to specify which interface that's going to be, which is going to be that GI03. Which will just make sure that those OSPF messages don't actually go out those particular interfaces. So we can just hop over to kind of make things go a little bit quicker as we've kind of done here and just go to the final configs. So we're doing this on router 2 and router 4. So we can go ahead and copy that right there. Let's get into router 2. So router OSPF 2, and then the router ID of 2.2.2.2. And remember, the instance that you use for your OSPF configuration here, so router OSPF 2, really doesn't matter. You can make it whatever you want to make it. It's just, in this case, within the lab, it just kind of makes sense to go with something that matches the name of the device, but really you could use whatever you want to do. Just make sure that if you're doing it in an operational environment, you kind of have some type of, I don't know, rules as far as what you're following or guidelines as far as why you're going with whatever numbering scheme you are. So we did that. So we got that going there. And then we are going to do these network statements here. So it's going to be this 10.0.0.0.9 and then the 192 network as well. So at the moment, we're only doing the stuff that's going in area 0. And the last command that we're going to do there is that passive interface command, GI03. And then we can come down here to router 4. And we can do similar types of configurations over here. Again, we're just going to be starting up that OSPF instance. And then we're going to be doing the router ID of 4.4.4.4. And then we're going to be doing the network commands, which are going to be using the other IP on the other end of that /30, which I think is .10. Yep, so we're going to go network 10.0.0.10 and then 0.0.0.0 area 0. So if you remember, when we're doing this in OSPF, we're using not a subnet mask, but a wildcard mask, which is pretty much the inverse of a subnet mask. Covered that in one of the other videos. I think it was either lab 2 or lab 3. And we're going to do that LAN segment, which was that 192.168.4. And in this case, all of these that I'm adding in here, we're just doing this /32, so just the individual IP address. We could do the whole /24 if we wanted to, but just here we're just doing that. So at this point, we should be able to do a show IP OSPF neighbor. And we see that we have a fully established state with 2.2.2.2, so router number 2. So at that point, we should be good with what we wanted to do with that first task. So let's take a look and see what the next task is. So we're going to set up OSPF in area 3. So that's down here with network configuration commands again. But we're going to set up OSPF so that there is no inter-area or external LSAs, link state advertisements, and only a default route. Then we're going to do no OSPF packets out the LAN interface on router 3. So pretty much what we were kind of doing before with that passive interface command. And no log messages when type 6 LSAs are received. A default route in R4, in router 4, should have a route metric of 333. We kind of covered this before in one of the other labs as well, as far as changing the route metrics. If you remember that the key thing in that, the whole purpose of that, or the way that we go about doing that, is we have to take whatever the number is and end up subtracting whatever the link costs are. In this case, everything is gigabit Ethernet. So the cost of these links between devices is actually 1. So I think what we're going to end up doing with that is end up doing 332, which then will have 1 added to it for that particular link coming over to router 3. So we'll see. We'll see how it all kind of plays out here. So I guess the other thing that we should mention here that we're going to be doing, so as far as no inter-area or external LSAs, only a default route. So in that case, we're going to be using the stub no summary command. I think that is going to be what we need to do. And if you remember, we kind of talked about all of these different types of areas and the different types of link state advertisements that go back and forth between those. So in essence, to ensure that we don't have any type 3 messages or LSAs coming through, so the type 3s are the inter-area, and no external LSAs coming through, and only a default route coming in. In essence, that is what's called a totally stubby area. So that's why we're going to go the stub and then the no summary command there. If we were allowing other types of type 3 LSAs to come through, then it would just be a regular stub area. Or yes, a regular stub area. Let's see. Okay. Let's go back to the configs that we have here, and we can go ahead and start on router 4 since we're already there. So we can go ahead. This is doing this, I believe it was router or area 3. So we're going to go area 3, no stub summary, like I mentioned. So we can copy that in. The other thing that I said that we were going to do is the making sure that the passive interface I actually think the passive interface that we were doing on that was going to be over here on this guy off of router 3. So I'll just double check that. Yeah, so that's going to be on router 3, not router 4. Okay. And let's see if there was anything else that we were going to do there. So as far as the default cost there, we were going to go with kind of how I was breaking that down, that we wanted it to be 333. It's being advertised from router 4 to router 3, that default route is. So what we're going to have to do is use that default cost, make it 332. The additional cost of the link, as I mentioned, because it's gigabit Ethernet, is going to be 1. That's going to get added to it. So then when we go and we look at the default route that router 3 has, it should end up having a metric of 333. Okay, now let's go to router 3. We can go ahead and create the OSPF instance here. Router OSPF 3, router ID 3333. We were going to be doing a passive interface on this one. And go ahead and we can add that. And then we got to add the other network statements that we have here. So we're going to have the /30, or the IP address on router 3 from the /30. So it's going to be .13. And then also for the 192.168.3.1. So we can go ahead and do that. We can add that in. We also need to make it a stub area 3 stub. Now remember, we don't have to do the no summary here because router 4 is actually acting as the ABR, or the area border router. And that's going to be the one that's going to be advertising the default route into area 3. Okay, so we did that. Now let's go back here and just make sure that we did. Yeah, see, I knew I forgot something. We did not put in the network statements there. So that would not have worked out so well. So we'll just get those. It's just one statement. So it's the other side of that /30. And drop that in there. Cool. Should be able to go back over here. Let's do show. There we go. We just see that that came up. Do show IP OSPF neighbor. Okay, we should be able to do show IP route. And you see that we have a default route coming from router 4, which is 10.0.0.14, right? It's the other side of the /30. And you see that the metric associated with it is 333. Now, we should also be able to verify that cost value. We could go ahead. Let's do a show IP OSPF database summary. Helps if I do a do in front of it. Show IP OSPF database summary. And we see that the route there, which is for the default route, has a metric of 332. So that's what's being passed, and then it's having that additional cost be added to it because of the cost of the link. Again, being gigabit Ethernet and it being a value of 1. So I think that covers what we wanted to do on task 3. So let's take a look at what we have for task 4. So we're going to set up OSPF areas, multiple OSPF areas. We're going to do 1 and 2. So we have 1 up here, and 2 is going to be over this connection here. And then with those, we're going to be doing it with a network configuration command. We're going to be adding some authentication. So we've done this in previous labs, so we're kind of recapping this. So we're going to be doing plain text authentication within area 1 and MD5 authentication within area 2. Remember that when you do that, you end up having to make sure that those interfaces, when you specify that for the area, that you are doing the authentication, or else you're not going to be able to get a solid connection there and be able to share your routes. Let's see. We're going to do a default route. Oh, I'm sorry. I jumped up a line there. And the key that we're going to be using is JBC, just like we've done in the other labs. So let's hop into router 1 first, and we'll work on area 1. We're going to router OSPF 1, router ID 1.1.1.1. And then we can go and take a look and see what it is that we're going to be doing within that. So we're pretty much going to be adding the network statement for that connection over that /30, which is going to be this one here. And let's see what we got. I'm just looking through my notes to make sure that we are good with that. And so the way that we're going to be doing that OSPF authentication there, it's going to be underneath the actual interface. So we're going to go int gi 0/0 and IP OSPF authentication, then IP OSPF authentication key JBC. So in this case, we're not using the MD5, we're using just a plain text. And you'll also notice in this case, we haven't specified this under the area, just under the interface. So if we go over to router 2, we've already set up our OSPF instance over here. So we don't need to do that. We're just going to add the network portion of that. And then area 1. Oh, it does help when I'm under OSPF 2. There we go. And then we're going to go under the interface, just like we did on router 1. IP OSPF authentication. And you notice, because we have it already configured on the other end and not here, normally if we didn't, we would end up seeing that connection would come up. So if we do show IP OSPF neighbor, we see that we actually don't have anything established there yet. authentication key JBC. And there we go. Now we see that we have that up there. Okay, so that was good as far as getting Area 1 up. We also can verify the authentication that we're using. We've used this command before. So in this case, since we're doing it under interfaces, we do show IP OSPF interface GI00. And under that, we see the IP address, the process ID, the type of stuff. But really what we're looking for down here is the fact that we're using simple password authentication and it's enabled. If we were to look at the other interface going down to router 4, then let's see. Oh, meant to do 0, 1. There we go. You see down at the bottom here, we don't have anything mentioning any type of authentication because we don't have it configured there. All right, let's go back to router 1 and then create this other area. So we did area 1 here. Now we're going to do area 2. And we're going to do, instead of the plain text authentication, we're going to do the MD5 authentication. So we already have the OSPF instance already configured, so we can pretty much go under router OSPF 1, and then we go network, should be 10.0.0.5, I believe. Let's just double check. Yep, that's going to be .5. 0.0.0.0, and that's area 2 is what we're doing here. Yep. And then we're going to go for the message digest. We'll go area 2, authentication, message digest, and then go under the interface again, GI01, and go IP OSPF message digest key. You can go really whatever type of key ID here. You just want to make sure that that you go with one of the numbers in that range. MD5, and just to show you, that's really the only option we have, and then JBC. You could have multiple keys assigned here as well if you wanted to. So that's the whole point of having all the different key IDs. All right, so we can go ahead and do that. Now let's go down to router 4. We're going to go into router OSPF 4. And then network 10.0.0.6 is the IP on the other end of that. And that's 0.0.0.0, area 2. Pretty much just doing the same thing that we did on router 1 here. So we do have to add the area 2 authentication message digest. And then under the interface GI01. And you see, since we just configured that, but I haven't put in what the key is yet under that interface, no valid authentication send key is available. So we're already getting some errors saying, hey, we're missing something. So we can go IP OSPF message digest key 1 MD5 JBC. And then with that, as long as everything functions as it should, then we see that the OSPF adjacency has been established, and we now have a new neighbor there for area 2 connecting back to router 1. We can take a look at the neighbor. There we go. Beautiful. Now, one of the things that you might end up knowing from your OSPF studies is that the higher IP address between neighbors should end up taking the priority and end up becoming a designated router, as long as it is a type of OSPF network that has designated routers and backup designated routers. Sometimes what happens, though, depending on which one ends up coming first, one with a lower IP address might end up coming back up. I think that normally will end up working itself out. If you are really stressed about that, though, you could actually just reset the processes on the different devices, and it should end up coming back up the way that you're expecting it to, with the higher IP address taking the role of the designated router. You also could do something like mess with the priority. So I'm kind of here talking about router ID versus priority. The router with the highest priority ends up winning, and the default is 1. You can set that on a per interface level if you want to. All right, so let's see if I think that took care of all we needed to do for task number 4. Any questions so far up to this point? You can throw those in the chat section if you want to, and we can move on to task number 5. So we are going to set up an OSPF area 4. I'm going to do that up here. And we want this to be an ASBR. So remember, an area service border router, so that we can import routes as type 7. So kind of external routes. The interesting thing with doing this, though, is the fact that this area, if you look at it, has no connection back to area 0. And so that's kind of one of the fundamental rules of OSPF, is that any of these areas, in order to be able to share its routes with all the different areas, it needs to have a connection back to area 0. So in one of the earlier labs, we looked at this. We had a similar problem where we need to do that, but the problem was the areas in between the remote area that didn't have a connection back to area 0 and area 0. So like the area that was lying in the middle was configured as I think it was a not so stubby network, or it might have been a stub network. And the problem with that, and why we ended up having to use GRE tunnels to be able to do what we needed to do, is because the technology or the configuration that we want to do here in this lab today, which is called virtual links, isn't allowed and isn't supported through those types of networks. So in this case, because of the fact that area 1 and area 2 aren't NSSAs or stubby networks, we actually can use those virtual links now to ensure that area 4 has a connection back to area 0, and we're able to share all the routes. So that's kind of what's going to be required here to make sure that all of the different areas can actually ping this subnet. So let's hop into router 1, and we can take a look at that. Go back into the OSPF instance, and we're going to go network 192.168.1.0 slash. I was going to go /24. That's hilarious. 1.1. There we go. Oof. Really wanted to use a /24 there. And that's going to be area 4. And that's cool and all that. But let's take a look and see like what these routing tables look like at the moment. So we added it into here. Now router 1, since we were there, do show IP route. seeing it because it's directly connected, right? So we have that there. And let's see if we're actually seeing this over. Do show IP route. And you see here, because of the fact that it's not connected to area 0, we're not getting that route over here on router 2. Let's see if we can see it on router 4. And it's not being advertised. We're not seeing it there either. And we can pretty much assume that this is going to be the case over here, but we'll just do it anyway, just because we're going to be thorough. Okay, so let's go ahead and look at creating those virtual links and what that actually takes to do that. I guess the other thing that we should end up doing with this is make sure that we are configuring this away. So they wanted it to be able to import type 7 routes. And so what that means, but no type 3 and no type 5. So we keep going back over to this page, and I put the link for this in the description to kind of, be able to figure out what it is, the type of areas that match kind of these different requirements for different types of LSAs. So in this case, type 7 LSAs are generated by the ASBR and converted into type 5 by the ABR to be flooded to the rest of the OSPF domain. So in essence, what we need to do here is create a not so stubby area and eliminate the type 3 LSAs. I think that's what we were talking about. Yeah, no type 3 LSAs. And so it's going to be a not so stubby network with a no summary command as well. There we go. Area 4, NSSA, no summary. Okay. Now, let's go ahead and look at creating these virtual links. These are really straightforward. These are not hard to do at all. So, in essence, we have a few different areas that we're going to end up using to create the virtual link over. So if we go back and look at the diagram here, we're going to be creating a virtual link across area 1 and a virtual link across area 2. So for the area 1 virtual link, all we're going to do is say area 1 virtual link and the router ID of the other router that it's going to be connected to, which is going to be over on this side, which is a 2.2.2.2. And then the area 2 virtual link is going to be 4.4.4.4. Pretty straightforward. Now the thing is, we do have to do this on both sides of these virtual links. So we did it on router 1. We're going to go on router 2. And we see, because we haven't done it yet, received invalid packet mismatch area ID from backbone area, because we haven't configured that virtual link yet. So we go router OSPF 2. And we're going to go area 1 virtual link 1.1.1.1. And you see when we do that, we end up getting this other adjacency that ends up being formed. And it's going to be OSPF underscore VL virtual link 0. So do show IP OSPF neighbor, and you should end up seeing that there. Yep. Okay, now let's go down to router 4 and do this as well. And see, we're getting the same mismatch area ID errors here because we haven't configured this yet. Router OSPF 4, and it's area 2 virtual link 1.1.1.1. Same thing happened here. Do show IP OSPF neighbor. And now we see that again for this virtual link. So we can also go back to router 1. And we can use a command that will end up actually showing us the virtual links that are configured. So we're going to do a show IP OSPF virtual links. And so this shows us virtual link 1 is going to 4.4.4.4. And gives us some other interesting information. Shows us the interface that's going out of, the cost that's added to it, the state of what it is. In this case, it's a point-to-point. And I think that's pretty much what we want to see as far as having the virtual links up. Now, so if we go back to router 3 at this point, remember, so we did the show IP route. We weren't able to see that route for the 192.168 1.1. We should be able to show IP route. Well, I take that back because we actually did have a default route here. So me actually going to this router might not be the best one to look at, because that default route, because of it being a totally stubby network there, isn't the best. So let's do this on router 4. It'll actually look a little bit better. Show IP route. And now you see that we actually are seeing that one network there. We do ping 192.168 1.1. We can do that. We can do it from router 3 as well. Beautiful. It's working good. Remember before when we did this up here, we didn't have it in the routing table. Do show, we can double check though. Do show IP route. And now we are seeing that coming up. So perfect. I think that that kind of covers all of the things that we wanted to make sure that we had there for that task. Let's go back and see what the next one is. Configure the virtual link between router 1 and router 2. Router 1 and router 2, the one going over area 1, with a cost of 2. And then the one between router 1 and router 4 with a cost of 4. So at that point, that's going to kind of modify which route should be preferred there. So by default, the virtual link cost is derived from the interface cost, which in this case is both 1. So to modify the virtual link cost, we're going to modify the cost of the interface that the virtual link is established across. So in this case, GI00 and GI01. And we kind of already looked at what those costs were when we did the show IP OSPF virtual links command. So pretty straightforward here what we're going to be doing with that. If we go back up here and look, that command still might actually be there. Yeah. So cost of 1 and cost of 1. So we can go under the interfaces. Interface GI 0, 0. And I think we were going to do link between router 1 and router 2 with a cost of 2. So we'll modify that. IP OSPF cost. We're going to go 2. And then we're going to go interface GI01 and IP OSPF cost. I think we're going to go 4. Let's just double check. Yeah, with a cost of 4. Okay. Now, if we go and run that same virtual link command again, we show IP OSPF virtual links. And now we see that the cost is different there, right? We see that that one going down to router 4 has a cost of 4, and the one going down over to router 2 has a cost of 2. So not too bad. But good way if you want to make sure that you have some different ways besides your bandwidth or your interface costs that you can statically set things, then that is a very useful command. So let's take a look. So the last thing that we have here is we're planning to put in 10 gigabit interfaces somewhere into the network. So there's some additional configurations that we want to do with that, because OSPF calculates route metrics based off of what it believes the default interface cost is. So this is very easy to do, but it's important. So by default, OSPF uses a reference bandwidth, is what it's called, of 100 megabits per second, which is kind of crazy at this point because I think it's probably pretty hard to find some network devices, you know, at least made in the past 15 years that has 100 meg ports, but that is what OSPF is doing. So it's calculating the cost for the values of links. It's using a default of 100 megabits per second. So if you change the value on a router in your network to whatever, I don't want to think how I want to articulate this. When you have higher value or higher speed interfaces, you want to change that configuration on your device to be able to support those higher speeds so that it has a better value within OSPF. But when you do that on one device, you pretty much have to do it across the rest of the devices in your environment. So that's kind of the important thing to take away from that is modifying the reference bandwidth so that OSPF is actually recognizing that you have higher speed interfaces within the environment as what might be the default there. And then making sure that that configuration change is pushed out across the rest of your devices that are participating in OSPF. So it's pretty straightforward. There's nothing too crazy with this. We're just going to go under the OSPF processes on each of these devices. So router OSPF 1, and then the command is autocost reference bandwidth. And then the reference bandwidth is in terms of megabits per second. So we're going to go not 1 gig, but 10 gigs. And they even give us a nice little message there. Please ensure reference bandwidth is consistent across all routers or network devices that are going to be participating in OSPF. So we can go ahead and just drop this on all these other switches. Router OSPF 3. We can drop that there. Auto cost, reference bandwidth, 10,000. Okay. So now if we want to verify that this has actually been implemented properly, and we can see what the reference bandwidth is, we can do a show IP OSPF. And let's see where it is. Here we go. Reference bandwidth unit is 10 gigs. So it now has that, and it now will be able to calculate based off of this being the reference bandwidth used to calculate cost for the values of links. now that it knows that there are 10 gig interfaces within the environment. And I think that about wraps that up. So yeah, pretty good. I enjoy doing all this OSPF stuff. It's been a minute since I've actually done all these different things. So over the course of 4 videos, just kind of recapping the different things that we've done, creating OSPF processes, so getting the routing process for OSPF configured on different devices, routing for networks in OSPF using both interface commands and network commands. We've done different types of authentication, both plaintext and MD5. We've looked at the different types of OSPF area types, right? So we've had our regular areas, our stubby areas, our totally stubby areas, our not so stubby areas. We've done some redistribution of external routes, some redistribution of connected subnets, some redistribution of static routes. We've done some stuff modifying the metrics that go into these different routes being sent across. We've done configurations dealing with injecting default routes into different types of areas. I'm trying to think. That was, well, the virtual links, right? So different areas that don't have connectivity back to backbone. We've looked at how to overcome that issue if you have a not so stubby area or stub area or totally stubby area in between that kind of remote area in the backbone, and using GRE tunnels to be able to do that. I'm sure I'm forgetting a few things here. Oh, prefix lists, right? We use prefix lists to kind of manipulate what types of routes were being sent in and out of different areas. We also use passive interfaces. So kind of, figuring out which routes we actually want to send out, how to not send routes out. So we've covered quite a bit. And so if you're studying for the CCNP, I hope that this has been useful to you. I hope that having some configurations and some videos to kind of watch as you go through that, it's helpful. If you're studying the CCNA, I know that this is a little bit more in depth than what the CCNA actually covers, but really when you look at this stuff, it's not that much harder. So I think sometimes it's helpful to kind of look at the bigger picture and how all these things kind of work together. So, and especially having the configs right there to go back and check. Yeah, I hope it's useful. I think it is. So if you have any questions or comments, go ahead and throw those in the comment section of the video, and I will answer those as best I can. As I mentioned, we are going to start doing some BGP labs next, so that should be really exciting. I have a lot more experience, or I should say a lot more recent experience doing and using BGP. OSPF, it's been a few years since I've had to actually architect or implement OSPF anywhere. So a few other things I'm wrapping up. Going to do part 3 of my network automation CI/CD pipeline video. That should be out sometime in the next week. And I'm going to start doing some AWS networking videos. So I think that will be kind of cool. I don't necessarily see a lot of content out there as far as looking at building out and deploying networks within AWS, especially from the perspective of someone who's a network engineer. So hopefully that will be cool and useful too. As always, smash the like button, subscribe to the channel. Have a good week. Let me know anything else that you want me to do. And yeah, we'll chat soon. All right. Bye.